So let's finish this test here. Number 9, we want to make this function continuous. It's a piecewise function. You've got 2x plus a plus b, which is a line, x squared minus 3, which is a parabola, and 2a plus bx, which is a line. A and b are numbers. We don't know what they are. They could be anything, honestly, but we want to pick the right a and b that are going to make this thing continuous. Now, we know that the first part of this guy right here, 2x plus a plus b, is a line. That's already continuous by itself. X squared minus 3 also is continuous. It's a parabola. And 2a plus bx is continuous. It's a line. So the individual pieces themselves are not the problem. The problem is where the splits are. So for instance, the graph of f of x is going to be 2x plus 8 is a line all the way up until x equals 3. And once we get to 3, it's going to jump to x squared minus 3. What we want to happen is that there is no jump. We want 2x plus a plus b to end exactly where x squared minus 3 picks up, so that there is no jump. We want them to connect, like maybe 2x plus a plus b looks like that, and then x squared plus 3 would fill in the hole, and then be a parabola up until you get to 10, and then 2a plus bx would hopefully be another line that just goes off like that, so they're connected. Alright, now you can pick any a and b you want, but the problem with that is that, I mean, you might get something like this, where they're not going to be connected, and that would be a problem for us. So, the question says we want a and b, so this thing's continuous. So all you're really going to do here is find out where this thing is going to be when x is 3, which you're going to plug in 3 for x, and you get 6 plus a plus b. Now this is a number. We don't know what a and b are, but 6 plus a plus b is going to be some number. We want it to be the same exact number as when we plug 3 into x squared minus 3, because that way they're going to meet. When you plug 3 into here, you get 9 minus 3, which is 6. So we need this equation to happen. We need the equality here. But we also need x squared minus 3 to meet 2a plus bx when x is 10. So at 10, this is going to be 100 minus 3, which is 97. We need 97 to equal what this thing's going to equal at 10. When you plug in 10, you get 2a plus 10b. Now we've got a system of equations. It doesn't matter how you solve it. I'm going to do substitution. But you can try elimination, or I mean whatever floats your boat, honestly. But over here, I'm going to do minus 6 on each side here. So they're going to go away. So bam, bam, gone, gone. So a plus b is 0, which is easy. So a is just negative b. Great. So as long as a is negative b, this equation right here will be true. Now we got to use that fact to make sure this equation over here is true. So if a is negative b, this equation is going to become 97 is equal to 20. My God. Let me erase that. Where's my eraser? Here we go. Okay. 97 is going to be equal to 2 times a, but a is just negative b. So it's negative 2b plus 10b. So 97 is equal to 8b, which means b is equal to 97 divided by 8. Okay? And if b is 97 divided by 8, then a is negative 97 divided by 8. And that is the answer we're looking for. You can plug both of those back in and make sure it works, but I'm fairly confident that it will. Hope I'm not wrong about that one. Okay, last one. IVT. Can we use IVT to show that the function in question, tangent x and number a, or letter a, has a 0? Okay, HP, get out of here. Can we show that f of x has a 0 on the given interval? If not, explain why. If so, prove. Okay. Well, IVT, for IVT to work, you need 2 things going on here, okay? You got to show 1, that it's continuous on the interval, and 2, we got to show that f of one end, so f of, that's an a, is less than the value in question, so the y value we're looking for, which is less than f of b. Or, it could be backwards, f of b could be less than y, which could be less than f of a. In this case, a is pi over 3, b is 2 pi over 3, and the function is tangent x. And the y value we're looking for is 0. We want to show that it has a 0. Now, I could have given you any number. I could have said, show f of x has to equal like negative 3. It doesn't matter. Then y would be negative 3 down here. But right now the question is 0, so y's are zeros. Okay, so here's how we're going to do this. Let's clear this out. First thing we're going to do is number 1. Is f of x continuous on that interval? Well, hopefully you've got at least some notion of what tangent looks like. So we're going to write f of x, which equals tangent x. Now we're either going to say it's continuous or it's not continuous. If it's continuous, then we got to go to step 2. If it's not continuous, we're done. IVT can't be used. Well, tangent, if you don't remember this is how you should think about this. Tangent is the same thing as sine over cosine, which is a fraction, and the fraction will be undefined when cosine equals 0. Cosine is 0 at pi over 2, 3 pi over 2, negative pi over 2, I mean a bunch of places. We just want to make sure that none of these numbers are on this interval. Now it turns out pi over 2 is on this interval because pi over 3 is 1/3 pi, pi over 2 is 1/2 pi, it's a little bit bigger than 1/3 pi, and then 2 pi over 3 is 2/3 pi, which is bigger than pi over 2. So it turns out that tangent is undefined at pi over 2, which means since pi over 2 is on this interval we were given, we cannot use IVT, because IVT only works if the function is continuous on the whole interval. And tangent is not continuous on the whole interval. It's continuous everywhere on the interval except for pi over 2. But if it's discontinuous at one point, then IVT can't be used. So that's what you're going to say. I already saw that stuff. You're going to say this. Number 1, f of x is discontinuous at x equals pi over 2. And then therefore IVT cannot be applied. That's all I gotta say. And if you, I mean, you don't need to draw this, but I'm just going to show you real quick. Tangent looks like this. You've got an asymptote at pi over 2, pi over 2. So this is pi over 2 right here. And tangent looks like this, dude. And then it starts again right here. It's got another asymptote at 3 pi over 2. Okay? Now, the points that we're looking at here that we're interested in, where's the color? In color, here we go. Blue. Pi over 3 is somewhat, we know it's a little bit less than pi over 2, so it's back here somewhere, and there's a point up here. Great. It's positive. And 2 pi over 3 is a little bigger than pi over 2, so it's down here somewhere. So you can see that the function tangent does go from a positive number to a negative number, and maybe you would be inclined then to say that it has to go through 0 because it goes from positive to negative. But that's not true because the function's not continuous. Alright? It jumps from positive to negative. It completely jumps over 0 on this interval. Okay? Now, I'm not saying it doesn't go through 0 anywhere. Like, it goes through 0 at 0, so it should be 0 there. It goes through 0 at, what, pi? But they're not the points in question. The interval is from pi over 3 to 2 pi over 3, so we got to look on that interval, and it does not go through 0 in that interval. Okay, anyway. So IVT fails to, we just can't apply IVT on that one. Alright, let's check out B. So, get out of here. Go back to my pen. Go back to red. I'm using a lot of red. F of B, or f of x is sine x. Well, we know sine is continuous, so that's fine. So I'm going to forget A for right now. We're going to do B. So number 1. So I guess you're going to write this. This one's going to work out. And the reason that I know it's going to work out is first, sine is continuous. Second, sine of 2 pi over 3. And maybe like you would write this in the margin. This would not be part of your answer yet. You would just check this because you need this to happen. Sine of 2 pi over 3 is a positive number. It's root 3 over 2. Sine of 4 pi over 3 is a negative number. It's negative root 3 over 2. So since sine goes from a positive number to a negative number, and it's continuous, that's key. And the fact that sine is continuous means it must go through 0. Now, regardless, you should know what a graph of sine looks like anyway. But even if you didn't, look something that's a terrible looking graph, but that's what it is. Here's pi. So 2 pi over 3 is 2/3 pi, a little bit less. It's up here, right there. And sine of 4 pi over 3 is negative root 3 over 2. So 4 pi over 3 is up here somewhere. So we're down here. And you can see, I mean, this is the graph. You can see it goes through 0. And really, this should be an easy question anyway, because where does sine equal 0? Well, it equals 0 at 0, pi, 2 pi, 3 pi. And pi is right smack dab in the middle of this interval. So you should be able to find out where this thing equals 0 anyway. But the difference between this graph and the last graph is it's continuous. So it goes from positive to negative. It has to go through 0. Tangent didn't because it could jump. It wasn't continuous. So we're going to say those two things. Since f of x is continuous, this is for B, by the way. Remember that. Since f of x is continuous, that's the first thing IVT needs. That's the first condition. And 2. You got to say that one endpoint is less than the number we're looking for, which is 0, and one endpoint is greater than it. So we're going to take the one that's less than it, sine of 4 pi over 3, and f of 4 pi over 3 is less than 0. I'm just going to say what it equals, which equals negative root 3 over 2, is less than 0, which is less than sine of 2 pi over 3, which was root 3 over 2. And now again, we're talking about the y values, not the x values. Of course, 2 pi over 3 is less than 4 pi over 3. That's fine. But the y values look like this. The y value at 4 pi over 3 is a negative number, which is less than 0, and the y value at 2 pi over 3 is a positive number. So this is how you set it up. You just say that at one end it's less than 0, at the other end it's greater than 0. And now we're going to say, since it's continuous and those things happen, by IVT, f of some number, again, you maybe don't know what number it is yet, but f, we call it c, f of some number must equal 0 somewhere on that interval. Somewhere on the given interval. 2 pi over 3 to 4 pi over 3. Remember, c is a x value. Okay, all we're saying is there is some x value, we're calling it c, where the function equals 0. That's what it says. Since f is continuous and it's less than 0 at one end, greater than 0 at the other end, then it must go through 0. Somewhere, some x value, it must equal 0 on that interval. Okay? And the question also says find it. So if not, explain why. That's what we did in A. And if so, prove the 0 exists. That's what we just did. IVT does all the work. We just check the conditions. Okay? And then you just say, well, IVT forces it to happen. That's the rule. All right, get out of here. And so now we're going to find it. I mean, I already found it on the graph over there. But basically, when it says find where this thing happens, all you need to do is solve the equation. Where does f equal 0? And again, we're doing 0 because that's what the question asked for. I'm repeating myself here. If it asks for show that f has to equal 8, then it will be f of c equals 8 down here. If this all worked. Anyway, so we want to know, find it. Find out where it equals 0. Well, where does sine equal 0? Well, hopefully you solve this. It equals 0 at pi plus 2 pi n, if you want to write it like that. And it also equals 0 at 2 pi plus 2 pi n. Okay, that's a very simple way of writing it. But really, technically, both these numbers can just be combined into pi n. So x equals pi n is the answer. Now, there are infinitely many times where sine equals 0. We're only looking for the times between 2 pi over 3 and 4 pi over 3. So our options here for pi n would be like negative pi, 0, pi, 2 pi, 3 pi, 4 pi. You get it. It just goes on forever this way and this way. The only one of these that is on the interval, pi, is pi. Pi is between 2 pi over 3 and 4 pi over 3. So the answer is c equals pi. And that's it. Again, if you see IVT, just check the conditions. Two conditions. Is f continuous? If so, check the second condition. Is one endpoint less than the value that we're interested in and one point greater than the value that we're interested in? If so, then say, by IVT, f must equal whatever number somewhere on the given interval. If these two things fail to happen, if one of them fails to happen, then IVT cannot be applied. That's all you're going to write. All right. Hopefully that helped. Shoot me an email if you need anything else. And hopefully I'll either see you Monday or you guys can, I don't know, check back in, get more help. Whatever. Have a good weekend. Take it easy.